Hello, everyone. Can you hear me?
Yeah.
Okay.
Yes.
Yeah.
Good morning, everyone. We are fixing.
Sorry, would you mind a bit louder?
Okay. Wait. Let me. Hello. Test. How is this? Test.
Okay. Fine.
Okay. So we are fixing a technical problem in the physical class. Please wait one moment before we start our class.
Okay.
So the online student, you can see me, right?
Yes.
Uh,
Yes.
Okay.
Yeah.
And the visualizer cannot, but yes. Now? Okay. Okay. Oh, okay. Yeah. So with the increased cases, of course, we understand that the students are worried about it. So we are here to assure. So for those of a red zone like Sabah, they actually be back to campus, and you are recommended to wear a mask. Okay. Practice social distancing and temperature screening at certain locations. So according to MOH, students that return to the campus in July are recommended to stay in campus and also implement it. So this is very important. If sick or unwell, please seek medical support immediately. Always put on a mask and so one last thing from always check your mail. If there's any official announcement, information, or instructions, we will communicate with you via the official channel. That's all from me. So if you bring your laptop, I think try to log in first, just in case. Who didn't bring laptop? Oh, so many. But if you have a phone. Online student, can you see the whiteboard?
Yeah.
Yes.
Okay. So in case we can't, the IT is fixing the problem in the class now. In case it's not fixed, I will probably have to use the whiteboard. Yeah. So that's what I can think of for now. Okay. So please wait one moment. IT is here. He's still fixing.
Okay.
可以试试看回去。如果 OK， 现在可以放回去，可以开始干嘛？
那个可以，然后这个不行。
我现在在 Windows 上，你。OK， 诶。VGA 呢？那个 Windows 有声音 ，that means the computer。哦 ，OK，finally。那个。哦，声音不需要。不需要啊，
需要
不重要。
就插这根线。
OK。
但是你已经没地方插了，你已经插了耳机了。
对，不用剪播，不需要，暂时不需要声音。好，现在有这个就可以了。
好。
OK， 谢谢你。Bye bye, thanks. Okay, sure, thanks. Finally. Oh my God. Okay, so now we are in business, I think. So physical and online class, you can see my hands. Can you?
Yes.
Okay, so So what I will do is I will teach mainly using this and my webcam is still on. I think you can still see my face. And if you are online, you can write questions or just talk to me on questions. So I have my headphone on, so I can hear most of you. And I will record the session also, and after this I will upload whatever we discuss in the class in the Moodle. Okay, so now finally all problem has been solved, so I can start to begin the class now. So let me take my stuff. Okay. So we are here to learn PHY 101 mechanics. Okay, so these are the information that you can find in Moodle. And first, I guess, I should introduce myself, right? My name is Lim Yan Keng. I'm the lecturer for this course. So most of you are in the physics program, and some of you are from the mathematics program. So we'll be learning about basically this is the first year undergraduate course for physics students or the physics degree, right? So we'll be learning things about Newton's law and stuff like that. So a lot of things we will cover, you may have seen before already in your high school, but it's a similar thing, but it will be more and more difficult. Okay, so the first few lecture, maybe it's very easy. So a lot of students, right, maybe you see, so easy, then relax. But suddenly it will get more and more new things that wasn't covered in the high school before, right? So I wouldn't say difficult yet. It's still first year, right? No problem. But a lot of new things. And so this is what I would advise is, try to follow the lecture from the beginning, okay? Because some students, they will be like, they relax, and then 2 days before exam, suddenly, okay, study everything. For physics, I guess you know already, it's very difficult, right? Because physics is something that need practice, that need over time. So don't study everything the last 2 days before the exam. Just spread it out, and it will be much, much easier. Okay, so yeah, so that's me and my email here. So you can ask me questions through here. And our schedule is here already. So everyone is already here, right, at this venue and also online. And our next class will be on Wednesday. And office hours will be on this time slot. So during this time, nowadays for physical or online, it will be good for social distancing purposes. So office hours, you can contact me online also lah. Right? If it's less, maybe one person by yourself, maybe can come to my office, maybe, right? If too crowded, no good, right? Then our textbook will be these two references, Young and Friedman and Halliday and Resnick, but I will not follow them closely, okay? Also because you don't, I will, it's not compulsory to buy. I will not force people to buy it. I will have lecture notes uploaded in Moodle already. Then I will go to Moodle after this. Okay, so let me finish explaining this first. And then, yeah, so these are the important dates. We have a midterm test, final exam, and also the other continuous assessment. Okay, so for our course, we will have an assignment and 3 quizzes, a midterm test and final exam. So the weightage are seen here, right? So 10, 20, 30, and 40. For the assignment, right, it's usually for this university, usually the coursework is quizzes, but I'm trying to like make it more like fun or interesting, so that instead of quiz all the time, it's very stressful to have so many quizzes during the semester. So I changed one to assignment. So for the assignment, right, you are to answer a question in that I will show in the Moodle later. So assignment is I have uploaded like 6 or 7 questions about physics, okay, and these are like applications of physics. So your assignment is just to answer those questions, right? It's not like textbook question. It's like some real everyday life questions. So one question is like, you see helicopter, right? Helicopter got the rotor on top, right? But the tail got a tiny one at the back. What is the function of that tail rotor? Okay, so maybe you know, maybe you don't know. If you know, then you can answer it in the assignment. And along the way, you explain the physical concepts behind all those things. Okay. Another question is about the space elevator. So if space elevator is a proposed design for another method to travel into space. Because nowadays, the only way we can go to space is by launching rockets, right? So launching rocket is dangerous and expensive. So what they do, another idea people propose is, okay, what if you take an elevator? That means you need a building that goes all the way up to space. Okay, that sounds crazy, right? Is that possible or not? So you can read up about it. You will be surprised. Okay, so a lot of the questions are meant to be more fun things to think about, right? Not just boring quiz question. You solve Newton's law, blah blah blah, that kind of thing. Okay, so the assignment, and then we have 3 quizzes. Okay, so midterm test was okay, yeah, nothing much. Midterm test is we have 2 exams, so midterm and the final. The date of the midterm test, we will plan this to be on the 25th November. This will be the week 8, and midterm test will be during our class time, so no need to worry about timetable clash. Okay, so we can plan it this way. And most probably midterm test will be online. Okay, quizzes will be online. So by the way, the things that you need to submit is assignment and quizzes, which will be submitted online, so that everyone, physical student and online students, submit in the same way. So the questions will be, you write your answers, right? And then what you can do is you can use any software app to scan into PDF file, and you upload PDF file to Moodle. Okay, so I think at this stage I should go to Moodle. Everyone can still see my screen, right? I hope. By the way, online student, everyone okay?
Yes.
Okay, just checking.
Yes.
In case I suddenly mute myself, just let me know. Okay. So this is Moodle, and so our course page will be over here. So Moodle is where we download our course materials, lecture notes, tutorial, and also the same place where you submit your assignment and your quiz. Okay, so our course page is here. I think as a student, what you will see is, as a student, you will see this view. Okay, so these are the information that is relevant to us. Okay, and the lecture notes and stuff. So the course information was what I was using to show you just now. You can download everything here. Okay, and then important announcement, I will put it here also. But announcement will also be received through email. So make sure your email is not full so that you can receive email. Sometimes important announcement about exam and things like that will be sent through email, even from the OAA and everything. Okay, so announcements, and then this is where we can get our lecture notes. So after I'm done talking this, we will start talking about the first set of lecture notes. So everything is here already. You can download from here. Okay, so you can refer to this by yourself. And also along the way, I will talk extra things. You can make notes on top of it as well. Okay, so these are the lecture notes, and then tutorial is basically just exercise questions for you to try. So this one is no need to submit to me. It's for you to try, and then occasionally, usually at least once a week, I will go through the tutorial question and explain some of the answers to you. Okay, probably not all the answers, but the difficult ones, because in the tutorial there are easy ones. So if everyone finds it easy, no need to spend time on it. So the assignment is where you will submit here. So later there will be options for you to submit when the time comes for the assignment. Okay, so yeah, and let me open my lecture notes for when we start this later. Okay, so yeah, so the reason why I don't need to force everyone to buy textbook, because hopefully the notes, everything here should be complete enough already. But of course, if you want to refer any textbook, not just Young and Friedman, but any textbook as well, everything is more or less the same. That's why it doesn't really matter. Another good thing about buying textbook is textbook have a lot more exercise questions than my tutorial. So you can buy, if you have them, then you can exercise, do all these things yourself. Okay. Tutorial question is like usually around like 10 plus questions per chapter only. Okay. Then what else?
Can we buy digital version?
Sure.
Textbooks.
Yeah.
Okay.
Yeah. But if you want to buy, okay. No problem. Then what else? I think, yeah. Do you have any questions? Any other questions? So these are the main administrative details. So if I forgot anything, let me know. Otherwise, we can start talking about the main topics already. Yeah. So yeah, tricky problem today lah, because pandemic, right? You can buy digitally, or yeah, buy from bookshops. Yeah. So it's more like for you to buy whatever book you want. Okay. I won't be following the textbook closely. Right. Buy your own textbook for your own reference. Okay? So I have all the lecture notes there already, and I will be based on those notes. Okay. Anything else? Okay. So if not, I think we can start. Yeah, maybe I'll go through this very quickly first. Okay, so these are the things that we'll be talking about over this semester. So this is, as I said, this topic is about mechanics. Therefore, these are the main things we learn about, right? Kinematics, Newton's laws, work and energy, linear momentum. I believe all this you have seen some in your high school before, right? Right. So we'll go through this again, but the concepts are the same, but we will use more advanced language, a bit more mathematical than high school. And the questions that we'll solve maybe will be more complicated than high school questions. Okay. And then rotational motion, I don't know if you have seen this. Have you learned about angular momentum in your high school? No, right? Yeah. So that means this is the point where you start to see new things. Maybe gravitation you learned before a bit. We will talk a little bit about gravitation, and then oscillations, wave motion, and then special relativity. So we will try to cover these 10 chapters. Our pacing, this is just a plan, right? It will depend on how fast or how slow we can go. Some student may find chapter 2 very easy, we can go faster. Then suddenly, some students find chapter 4 more complicated, we can go slower. So it will depend on the situation, right? And these are the important dates. So week 1, this is today, the first day of week 1. And then these are the important dates to take note. So on the 3rd week, we will start to do a trial quiz. This is nothing, just to practice everyone for practice on how to upload PDF file, right? Just try once and get used to your system. Okay, so I think a lot of students prefer to use cam scanner. When after they answer the question, they just take the scanner app using the phone, right? And then upload the PDF file to the Moodle. Okay, so this is where you practice that, and then the real quiz will start here. Okay, so maybe we will do it on probably Tuesday or a Wednesday. I will upload the quiz on a certain date, and then we will give 24 hours to finish everything and upload everything. Okay, so the quiz will be 24-hour period of time. Okay, then midterm test is over here. Probably is going to be online exam. Depending on the situation, it keeps changing. Seems like and then another quiz, and then the assignment is due on the very last day. Okay, so I'm trying really hard to make it very relaxed for everyone. I given you the assignment already today. You can see the question. You have the whole semester to just answer one simple question, right? Your answer is going to be maybe from 2 to 3 pages, right? Just answer, explain everything, and then you can choose whatever topic that you want, okay, from the question, and then final exam. So about the assignment as well. So the questions can be found here. Assignment questions. Yeah, open with Firefox. Okay, so yeah, so the main reason we have this assignment is to let everyone learn how to study things that is outside a classroom setting, because lecture notes, everything is handed to you, spoon feeding. But in real life, right, whether you're working or when you're doing PhD studies or research, right, you need to be an investigative detective. You need to find out information by yourself, right? So nowadays it means internet lah, right? You Google, okay? So it's still very easy, but in any case, it's still outside the classroom. So find out information to answer certain problems or certain questions. So space elevator here, and then this one I call this Australian bathwater, because there's a saying, right? If you're in the northern country, if you see your toilet bowl or your water sink, right? When your water sink flows down the drain, right, it will rotate in a certain direction. So people say that in the northern country, they rotate clockwise. Then in the southern country is anti-clockwise.
Dr.
Right?
Lim, excuse me.
Yes?
Your assignment questions are not showing.
Oh, not showing, is it?
Yeah.
Am I sharing screen?
We can see your screen, but we cannot see your assignment questions.
Oh, that's weird.
Yeah.
Okay, what are you seeing now? Can you see this thing? Can you see my hands?
Yes, I can see your hands.
Only your hands.
Oh, I think I know what's wrong. Wait, let me. Okay, sorry. Let me do again. Okay, technical things. I share my whole desktop lah. How about now?
Yes.
Okay.
Thank you.
Yeah.
Okay. Yeah, thanks. So let me know when things like this happen. All right. Yeah, like Teams lah, Zooms are always sure got this type of situation one. And the one I'm scared the most is accidentally muting myself. So just let me know. Okay. So I was talking about this, right? Yeah, the northern hemisphere things. Trebuchet is a catapult that in the olden days, during people fighting the wars, they launched something against a castle to destroy the castle, right? To break the door. Okay, so that one has a lot of physics involved. So yeah, read up on catapults and see how the thing works, right? It's obviously it's going to be a projectile motion. We're going to talk about this week. And how do you launch it? What is the heaviest thing you can shoot using the catapult, right? And then the helicopter things like this and historical astronomy. So this one, I find this interesting because in the olden days, right, people already know how to measure the mass of the Earth, the radius of the Earth, like such huge things. Without technology, people can still do that. So how do you figure those things out, right? So with limited technology, you need some kind of smart, tricky ideas to figure out all this information, right? So is it possible to determine all these things? Okay, and then this one is about G-forces. So jet fighter pilots, when they fly the plane, you know, they will undergo strong acceleration. And this will cause problem because the body cannot withstand acceleration. So how do you solve this problem, right? This one is about the pulleys. So what happens if you do not assume massless? In a lot of questions that we will solve in this course over the next few weeks, we assume ideal cases where the pulley is massless, right? So what if it's not? So can you figure out the answer? Other than that, if you have any other things you can that is not in this list but is worthwhile to answer, just let me know. Okay, you can still do it, right? Propose your own problems. Okay, so that is the assignment component, right? The main point is to let everyone have fun with how to use physics in real life, right? Not just answer boring quiz questions and things like that. Any questions about this? No, everyone clear? Okay. Yes.
So means that we just choose one topic for us, or we need to have pre-register for
So just inform me what topic you're about to do. Yeah, just inform, and then you can start doing. Right. So you have the whole semester to do it, right? So plenty of time. Okay. Anything else? Okay. So you can still see my screen, right? Okay. My handwriting is here. Okay. So let's go to our first topic. Let me close. Yeah, a lot of extra windows here. So let us start to talk about the first thing. Okay. So chapter 1, we are talking about kinematics. Okay. So what is kinematics about? Mechanics, right? We can sort of divide them into two categories: kinematics and dynamics. Kinematic is describing motion. Dynamic is why the objects move. Okay, so so that is what we want to talk about today, kinematics. So before we are able to do kinematics, right, we need to start with some basic concepts first, which is the idea of units and dimensions. So I'm going to start writing now. Yeah, hang on for a moment. Today is 5th October, right? So 5th. Okay. Hang on. You are writing? Okay. So we're going to start to talk about this. Okay. This is the introduction. The chapter numbering, I will generally follow the lecture notes. Okay. So the first thing that we want to talk about is about units and dimensions. Okay. And what do I mean when I talk about units? So maybe the difference will start to come in. The MAT students will notice this difference because if you are in math, right, every unit is dimensionless. You just talk about numbers. But in physics, the type of number we're talking about is important. Okay, whether we're talking about a length or a mass or a force, right? It's a number. So, and we cannot anyhow add up any two numbers, right? Only the same units can add up to each other. Okay, so we need to organize our understanding of the different types of quantities that we will be encountering in this course, right? So the first thing I want to talk about is what is the meaning of a physical quantity? Okay, so a physical quantity is it's a physical like thing that can be measured experimentally. So we say that it's a physical phenomena. and you can measure by experiment or observations, and it is represented mathematically. Okay, so an example, right, is length. Probably the first physical quantity everyone is familiar with. Since kids, we use the ruler to measure how long something is, right? If you buy a house also, okay, what is the dimensions of the house? How many feet by how many feet? That kind of thing. So, but in this course, of course, if you're a physicist, you will try to learn how to do this, represent this in mathematical equations. So let's say X is a symbol that we use to represent a length, right? And we report a number. I just simply give some number, 512, and then maybe it's in meters, okay? So that is where the dimension is important, okay? So because this part, right, this part is our unit, okay? So this part over here, we are using meters, okay? We can also use cm, kilometers, and other units as well, okay? If you're American, you will use feet or inches, okay? And other things, there will be other quantities of measurement. If you're an astronomer, you will use parsec or light years. Okay, we have an astronomy course later, right? If you, in 1 or 2 years, some of you may be interested to take. So that is the unit, okay? And besides the unit, this will be the number or the value. Okay, so this will be what you punch in the calculator and things like that, right? So when you do calculations, right, equation and symbol, it can only handle the value part. So you need to keep track of the units correctly by yourself manually, because calculator also can only do with numbers, right? It cannot handle units. Okay, so these are the basic, the most basic physical quantity. There are 3 basic physical quantities. Second one is mass. Okay, usually we call this m, right? And then I don't know, some number, and then we say kilograms, right? And then another physical quantity is time, which we will use often. Let's say 2 minutes. Okay, so 2 minutes is equivalent to 60 times 2, 120 seconds, right? So these are the example. These are the 3 basic units that we will be using very often, okay, throughout this course. So related to this physical quantity, right, we use the term called dimension. So dimension it has multiple meanings in physics. But in term relative to unit, right, dimension is telling you the type of physical quantity. Okay, so the type of physical quantity. Hang on, let me just double check the Teams, just make sure everything is okay. Okay, it's recording. Yeah, so if for some reason it stopped recording, just let me know also. Okay, so dimension is the type of physical quantity. So whether it's this type, or this type, right? So yeah, so for example, if let's say x is 512 meters, as we say, right? Then how do I represent something as a dimension? So the dimension, I will draw square brackets, and then is equal to L, right? So if it is a length. Okay, so when we're talking about time, right? So time, the dimension of time is time. So we use a capital T to represent time, and the mass will be m. So m square bracket will be, right? So this means this is the dimension of time, and this is dimension of mass. Okay, so time, length, and mass, MLT. So these 3 things we will be using quite often. Okay, so these are the fundamental physical quantities. Throughout the course, we will be combining them, mix and match to create derived quantities. So derived quantities is another type. Okay, so derived quantities means what we are doing is we are combining physical quantities by, okay, okay, there's only 2 the two main ways, by multiplying or dividing. Okay, not addition, not subtraction. Okay, so can only be multiplying. So let's state an example that we have been using. So let's say we have x is 512 meter just now, right? And then time, let's say 2 minutes of time, you can define a new quantity, and I call this v, and I define it by x divided by t. So everyone knows what this is, right? Right. So it's a kind of velocity. Okay. So it's 5.12 meters divided by 120 seconds. So if you work out the numbers, you will get 0.04266666, right? So for in terms of the units, right, you just treat this as a mathematical variable by itself. Just follow. So meter divided by second. So we have meters per second, right? Or you can say meters per second like this. Okay. And another difference from mathematics between physics and mathematics is because when it comes to physical quantities, right, it is a result of an experimental measurement. So experimental measurement have limited precision and limited accuracy. So it doesn't make sense to say that there are infinite number of 6 at the back of the number, correct? Right? So you don't need to give all, because it's probably not true that every term is 6 in real life, right? Because of experimental error. So what you can do is we can say that, okay, up to a certain number of significant figures, right? 4 to, let's say 7, okay, meters per second. So this is up to 3 significant figures. Okay, so usually for answering questions, it will be safe enough to report up to 3. Okay, the general rule is if you see the question, the data provider is how many significant figures, then you follow the question. Okay, question use 5, you use 5. Question use 1, you use 1. Okay, so this is up to 3 significant figures, right? Yeah, so this, after the end of the class, I will scan and upload everything I've written here, so that you can still refer to this after we're done. Okay. So the next thing is, yeah, everything is still basic stuff. We want to talk about SI units. So this one also a lot of people know. Yeah. To SF, you use the smaller one. Yeah, because the smaller one the weaker one will affect everyone else. You know, right? Yeah. So follow the smaller one. Okay. Any other question? Yes.
I think it's better to repeat the question again to make sure both the online class and the video class can hear it after you receive it.
Oh, yeah, good point. Yes. So yeah, you're very right. So just now someone asked if the question has a so a student asked me if there's a question that has a mixture of different significant figures. This is for the online student. I'm just repeating. For let's say a question data provider has 2 significant figures and then somewhere else 3 significant figures. Okay, so which one do you follow? And my answer is you follow the smaller one, the weaker, the one with the fewer significant figures, because the fewer significant figure is the least accurate. So that means whatever you calculate, you can only trust up to the weakest one, right? So yeah, is it clear? Everyone else clear? Okay. Any other question? Okay. Yeah. So remind me to do for that, because online student can only hear me, right? Cannot hear the other people. What else? What's next? Okay. So SI units. Okay. So SI units. In this course, we will use our standard units of measurements. We call this the SI unit. Okay, so this is the most standard type of unit that is used in the scientific community everywhere in the world. So if you're a scientist, right, you'll be using this. So it's make it more convenient because if you use different units, right, it's very confusing. So that's why everywhere around the world, we agree that if you talk about mass, we measure this in kilograms. Okay, if we talk about time, we measure this in meter. We talk about length in meter and time in seconds. Okay, so yeah, so kilograms, you guys know what I mean, right? And meters and second. Okay, and even though this is the standard one, but sometimes it is more convenient to use some other related quantities. Right, so let's say 1 gram, right? So 1 gram is 1 g. So 1 gram is 0.001 kg, am I right? Okay, so I believe everyone should also already know the scientific notation. If I use 3 significant figures, is 1.00 times 10 to the minus 3 kg. Okay, so if you don't know, ask me, but I think most should have learned this before already, right? So if I repeat too much also, it's too boring. Kilometers. Okay, so kilometers is 1 km is 1,000 meters, or 10 to the power 3, right? Millisecond, 1 millisecond. So the m is for milli, is 10 to the minus 3 seconds. Okay, so in the lecture notes, I have, this is the base unit, seconds, and there's a m here is what we call the prefix. To find the dimension of it, you just find the dimension of everything here. So x over t, then you just need to calculate the dimension separately. Okay, so the dimension of x was L and the dimension of this was t. So the dimension of v is, L divided by t. So LT minus 1, right? So this is the dimension of velocity. And using dimensional analysis, we can also provide the how to say, the SI unit directly. So for this, the SI unit is meters. For the T, the SI unit is second. So therefore, the SI unit for V is meters per second. Or some people prefer to write this way, right? So this is the velocity. Okay, clear so far? Let me check the software again. Still recording. Okay, good. Okay, so now let's go to a slightly more involved example. Hang on. Our next example. Okay, 1.1.3. So we will see this. We will derive this equation either today or Wednesday. An object starting from rest at time 0 with constant acceleration has this displacement given by this. Okay, so determine the dimensions, and then given the values, determine the answer correct to its SI unit. Okay, so we have the displacement formula is given by half a t squared. Okay. So now, what is the first thing is we need to determine the dimension of acceleration, right? So we can manipulate this mathematically first. So from here, we can say that a is equals to 2s over t squared, right? And then what is the dimension of a? So we just need to calculate the dimensions of everyone inside here. Okay, dimension of this, dimension of this, dimension of t squared. Okay, so now this 2 is just a number, it's dimensionless. So just put the dimension as 1. Okay, so just to write down here. So if it's dimensionless, just put 1. Okay, so it's nothing, right? It won't affect everything. This one is dimension of length, and then this is t squared, so dimension is t squared. Right? So therefore, what you will get is LT minus 2, right? So from here, you get the SI unit. This is meter, this is second. So SI unit of A is meters per second square, the acceleration, right? So yeah, and then after that, they provided the information. The displacement is 5, was it 5? 5 meters, T is 30 seconds, right? So 5 meters, T is 30 seconds. So what is the acceleration? The acceleration is just, A is just plug in 5 and then 3, 30. Sometimes I'm lazy to write the significant figures in the intermediate step lah. So I don't want to care so much, right? Just the final, as long as the final step, because intermediate step you waste too much time. Never mind. So you put it here. If I calculated correctly just now. Okay, so this will be the correct unit for acceleration. Okay. So everyone follow so far? Let's do one more example.
Yes.
Yes.
Can I ask a question?
Sure.
So the equation on the top, so should it based on only one circumstance, like when time is 0 and velocity is 0 too?
Correct. Yes. So I will explain the detail later. This is just to yeah. In fact, this one for this equation is constant, and then initial velocity is 0 and initial time is 0.
Okay, so only when initial time is 0 and the initial velocity is 0, right?
Correct. Yes.
Okay.
So yeah. So for the physical student, someone online just asked me that is this equation valid when the initial velocity is only 0, right? So that is this equation is only valid for when the initial velocity is 0 and initial time is t0. Okay, and additionally, this equation is only valid as long as A is constant. Okay, so we will talk more about it later, right? But for this one, it's just to show dimensional analysis. Okay, so why is this equation true or why is it not true? We will worry about this later. Okay, any other question? Okay, one more question to do, then we take a break. This one, okay, we talk about density. So this one should be still quite easy. A mass of a solid cube is 856 grams. So each edge have this length. So determine the density of the cube in SI units. So let's solve this. Okay, so this is example 1.1.4. We are talking about a cube. Okay, so the length of each side is 5.35 meters. The mass of this is 856 grams. So we convert this to kg. So 856 times 10 to the minus 3 kg, right? So in cm, we convert this to SI unit will be minus 2 meters. Okay, so the density is mass divided by volume. So we need to know what is the volume first. So the volume is L cube, right? So that means, okay, so let me write it in cm first. So 5.35 cm, because I want to show you something later. So it's distance cube, right? So you got 153.13 centimeter cube, okay? And now I want to show you how to convert into SI unit when there's a power here. So cm, right? Cm is 10 to the minus 2 meter, right? So this one you can actually write, this is actually 10 to the minus 2 meter cube, right? So this is 153.13 times this thing. So you can treat the unit like a mathematical symbol by itself. So in the end, you have 153.13 times this thing to the power 3 is 10 to the minus 2 times 3, 6, right? And then you have meter cube. Okay, so if you simplify this a little bit, you got 1.531 times 10 to the minus 4 meter cube. Okay, so just to convenient way to remember lah. So 1 cm cube is 10 to the minus 6 meter cube, right? So it's not minus 2 because there's a power 3 over there. Anyway, this is just the volume, right? Then to actually get the density, rho is mass divided by volume. Okay, so just take this divided by this 2. So 1 point mass first. 856 times 10 to the minus 3 kg divided by 1.531 times 10 to the minus 4 meter cube. So in the end, you get 5.59 times 10 to the 3 kilogram meter cube. Okay, so this is the density in SI units. Clear so far? Yeah. So this is the first chapter. Everything's still very easy, right? Yeah. So, but of course, take note, right? Don't relax too much because suddenly, like, don't pay attention. Suddenly, everything becomes too complicated. But in any case, it's 11 already. So I think we should rest for a bit. Maybe rest for around 5 minutes, and then we will continue talking about kinematics. Okay. Yeah, I will keep the meeting on, but I will pause the recording.
Okay.
Yeah. So online student can still talk to me. I will stop recording, but I'm still online. Okay. So yeah. Okay, recording. And everyone can still see my screen, right?
Yeah,
Yes.
yeah.
Yeah, no
Okay.
problem.
So yeah, about the textbook, it's not important, but just now I was talking and suddenly realized that yeah, it's even if you buy, it's quite worth it because it covers 4 courses in the physics program. Our mechanics is only like the 1/4 of that textbook. So just to show you the textbooks, so I put the reference is Young and Friedman here, and the other one is Halliday, Resnick, and Walker. So Young and Friedman, yeah, so you can buy online or go to bookshop, try to find it. Actually, our university usually before the pandemic, the bookshop seller will come to university to sell the books you can buy here. But because got virus, so they don't want to come. Then you can go online, whatever means you can find it is yeah, you can, if you can get it, then it's fine. So is this, and then the current one is the 14th edition. Almost every 2-3 years they come out with a new edition, but actually, to be honest, physics doesn't change since 2 years ago, right? So if you get the old edition, also still the same, right? You can find secondhand or something, right? If you go to Goodreads or Amazon secondhand, people, you can find them easily. Okay, it should be quite easy to find.
Excuse me.
Can we find them on Kindle?
On what?
Kindle, electronic books.
Kindle.
Yeah.
I think they have Kindle version. I believe so.
Yeah,
so.
because ebook is much convenient. So.
Oh.
Excuse me.
Yeah, I think they have. They should. This one have ebook for peer. Young and Freeman have. So the online student was asking me whether you can find this on Kindle or not. This one by Pearson they have, but I'm not sure about this one.
Excuse me, sir.
Yes.
According to the policy to Amazon, book cannot be shipped to mainland China, so we only
really?
use e-version.
Those e-version or Chinese company, maybe like online Chinese website.
It cannot be shipped to mainland China. All book a CD.
Oh, okay. Then don't, if you don't buy from Amazon, or maybe you buy from a different company, besides Amazon.
I have tried to buy it on eBay, and the sellers tell me the Chinese government said it's not allowed. So.
Oh, really?
We only can use like Kindle version or PDF.
Oh, okay. Okay. Then Kindle is Young and Friedman. Then, so okay, I didn't know that, but I will.
Or we can buy it in Malaysia.
you can definitely can buy in Malaysia.
Now I only can use Kindle version.
Okay. Okay, so then yeah, if they have Kindle version, then you can buy those as well. Yeah, so you go to this website pearson.com, and then you can try to buy somewhere here. So let's see. E-text this much. So this one is displayed in USD. But anyway, I think we can solve this problem later, because right now for our course, don't worry too much because we have my lecture notes. Okay, so my lecture notes have quite a lot of things already. So at least for the next few weeks, we can use those, right? So don't worry too much about that yet. Okay, so yeah, so let's go to our next thing. So which is kinematics in one dimension. Okay, so as I was saying, right, kinematics is about describing motion. So describing motion, and so I'm going to be talking about these things here, right? So it's about describing motion. And the first thing that before we are able to do physics, we need to know how to use the mathematics to describe all kinds of situations. So that's why we talk about kinematics. And the first thing is, of course, everyone also, this is again, things have already been covered in high school, but let us be more precise here. The first thing about kinematics is we need to describe how objects move. So in order to provide information on how objects move, especially we need to say in a more precise way in mathematical equations, right? Then what do we need? We need three pieces of information. So the first thing is the position, velocity, and acceleration. So if you know these three things, then we should have enough information to say how the object moves, where does it go, will it stop, will it come back, all this kind of information, right? So we need to learn how to use all these concepts. So let's start with the position. So the position is this, right? In kinematics, we are talking about moving objects. So when we talk about moving object, generally a moving object will have, obviously, if it's moving, right, it will have different positions at different times. So in terms of mathematics, I think mathematics students can already know that, well, it is good that to represent the position as a function of time. So this is a function of time. And because this is a position, again, we've done this many times already, the dimension of x is L, and this is a function of time, right? And in order to describe this position, right, we will also need a coordinate system. So coordinate system, when I'm explaining right now, is something that feels very easy, that is everyone feels like everyone knows already. But again, right, I emphasize coordinate system, when we go to more higher and higher level, there's more and more complicated things to understand, right? If you want to talk about, for example, general relativity, right, study cosmology and things like that, right? We have something called diffeomorphism invariant. That means we need to handle coordinate system very, very carefully. Otherwise, we make mistakes in our calculation. But right now, it's still easy. It's all starting from here. What I'm talking about is positions. Because when we just say a number, right? Okay, my position is 5. Then you ask me 5 what? What does it mean, right? You always need a reference point, right? 5 meters from the door, right? So that is the coordinate system. So that means position must be measured, or can only be measured based on a reference point. Okay, another terminology of reference point, usually we call it the origin. Okay, so for example, when we want to say, okay, I am standing at position 5 meters, and you say what? Well, I am 5 meters from a tree, right? So that means this distance is 5 meters, and usually we call this the origin of the x-axis. So this will be x equals to positive 5. And then if you're on the other side of your reference system, so let's say 2 meters, then you have negative 2, that kind of thing, right? So this is our origin reference point, right? So for x. Okay, so this is our position. So over here we say that my x is equals to 5 meters. Okay, so still very easy, but based on this, when we go to more and more complicated situations, it all comes starting from this, right? So once we have origin, right, another important thing is a related quantity called the displacement. Displacement is the change in position. Okay, so displacement is change in position. Okay, just now I was saying, right, a moving object will have different position at different times. So we want to know how much does it change. So let's say t1 is my initial time, which may or may not be 0. And t2 is my final time. Then my displacement is defined to be, usually we call the symbol s, right? Sometimes we use the symbol delta x as well to represent a change in position. And we define it as my final position minus initial position. Okay, so final position is my x calculated at time t2, and initial position is my x calculated at time t1. Okay, so this one is very easy, right? So related to this, we will also need a time interval, which is just the change in time, which is simply just the later time minus the initial time. Okay. So once we have these two things already, we are ready to start talking about velocity. We shall start with the average velocity. Okay, so what's the average velocity? So average velocity is defined as, okay, so this is not the velocity that we use. That comes later, but so we call this VAV for average, right? So the average is just the displacement divided by the total time interval. Okay, so this one is very simple, right? So x t2 minus x t1 divided by t2 minus t1. Okay, so from here we can sort of see, right? Especially based on this picture, right? This VAV can be positive or negative, right? So if my average velocity is positive, it is moving where? Positive means this way, right? So it's moving to the right, or we say forwards. That means I'm increasing x. Right? Why is this positive? Because my later position is a larger number than my initial position. So I have moved to the right. But if the opposite case, if my average velocity is negative, that means my later position is smaller than this position. So the difference is a negative number. It is moving backwards. Okay, so it's decreasing x. Okay, and it is implicit, but let me just emphasize, we are saying that t2 must be the later time than t1, right? Because we are talking about the time interval, right? From initial to final, right? We don't do it the other way around. Okay, so now, what is the SI unit for average velocity? We have hinted this already just now. So the SI unit is just delta x, delta t. Okay. So does anyone know how to calculate the dimension of delta x? It's just the length, right? The difference in length is still another length, right? 5 meter minus 2 meter is still another 3 meter. So it's L, and same thing for t. So this is LT minus 2. So SI unit is meters per second. Okay, so that is our average velocity. Okay, So if you want to describe motion, right, now that we have position and time and average velocities, we can describe them using a graph. So usually we can describe how objects move by using a position versus time graph. So usually what you have is one axis versus time. Okay, so this is time, and then this is x. So usually we say x is in meters and this is in seconds, right? And then we describe how an object move. And so object move something like this. Okay, so let's say at time 1, this is time 1. So my position is here. Okay, and then at time 2, let's say my position is here. So from here we can calculate xt1, and here is xt2. So the average velocity, if you notice, is actually this length and this length. So the average velocity is just this thing divided by this. Okay, so what does it mean by this thing divided by this thing? What does the quantity mean in mathematics? It means the slope of the graph. If you draw a straight line joining the points, right? So this is slope is equals to delta x delta t, right? It's just your average velocity. So the average velocity is the slope of this line in your position time graph. Clear? Make sense? Okay, so average velocity is, as you can see, right, average velocity is, oh yeah, before, it is the slope of the graph, and we notice that if the slope is higher, the velocity is higher, average velocity is higher. If the slope is more and more flat, more and more horizontal, the average velocity is slower, right? So more and more horizontal means the position doesn't change a little bit, even though it's a long time. So the motion is slow, right? High slope means, for a high slope, right, in a short time, you change your position a lot. That means you have to move very fast. So the slope will tell you how fast you are going, okay? So that is for average, but of course, average doesn't contain enough information, because as you can see, right, if you're moving this way, this object has been moving quite fast here, but then it's slowing down here, right? In fact, it's starting to go backwards here. So average velocity is not enough information. What you need is the velocity at the instant at a particular time. That means we want to have instantaneous velocity. Okay, so how do we calculate instantaneous velocity? Well, we imagine, right, this one can be measured at any time interval. So if I take a smaller and smaller time interval, the slope I get is closer and closer to the velocity at that time. Agree? So that is how we define the instantaneous velocity. Okay, so instantaneous, let me write this. Instantaneous velocity okay, so instantaneous velocity is, well, it is defined as v is taking the time interval to be smaller and smaller. So the shorter the time interval, the more accurate is describing how fast it is going when it's around here. So limit delta t going to 0, and then delta x divided by delta t. Okay. By the way, who doesn't know limits? Everyone knows a bit, right? And also in your calculus course, also you will learn in a bit more detail. But who knows what does this mean? The math student will know, right? Differentiation. Okay, because math student already took calculus 1. You guys are taking it now, right? Calculus 1. So it's the differentiation, right? So when you differentiate, what do you get? You will get the tangent. So this is what we call the tangent line. And it's also the instantaneous velocity. Sorry. Yeah, can see now. Clear? Follow so far? Okay, so that is the, like, very, again, it looks very easy, but must make sure everyone understand this perfectly, because everything will build on based on this foundation, right? Because I imagine, physics knowledge is something that you need to build on top of each other. So if you want to build a lot of things, the foundation must be strong, right? Must understand this perfectly well, right? Later, understand not so much, you can continue build later, but the bottom part is the important part. Okay, so yeah, let's practice how we manipulate these kind of things. Let's work out some examples. Okay, so 1 point average. This one average velocity is quite easy, right? So if you drive from KL to Ipoh, it's about 2 hours. So let's do the more real question that you encounter quite often is 1.2.2. Okay, so car is stopped at traffic light and then travels along a straight line, blah blah blah. But the important thing is the displacement as a function of time is given to you, right? B is 2.4, C is 0.12. So first thing is calculate the average velocity, and then later all instantaneous velocity and things. So average velocity, okay, you are given that xt is bt squared minus ct to the power 3. Okay, so b is given to be 2.4 and c is given to be 0.12. Okay, you can write it here straight away, but I prefer, yeah, it looks nicer like if I use b and c. So the first thing is I need to calculate the average velocity, right? So average velocity, I need to know at the time at 0 and then at the other times as well. So when x is 0, right, if I put in 0, I just get 0. So the position starts at 0. At 5 seconds, if you plug in 5 square plus this thing and then you times everybody together, you should get 45 meters. And then you do this again at 10 seconds. You plug in 10, you calculate the number, you get 120 meters. Okay, and then you want to calculate the average velocity between t1 and t2, which is 5. So my average velocity is, so you use these two numbers, so it's x5 minus x0 and then 5 minus 0, so it's actually 45 minus 0 over 5 minus 0, so it's no space, so it's 9 meters per second. Okay, then if you want to calculate between 5 and 10, so my average velocity is, I should use 5 and 10. Okay, so it's x10 minus x5 divided by 10 minus 5. So x10 was 120, right? And then 45, then 10 minus 5. So if you calculate this number is 15 meters per second. Okay, so the average velocity is different if you use different time intervals. So that is why people prefer instantaneous velocity as a more accurate measurement. So the instantaneous velocity is differentiating x with respect to t. So that my x is given here. So just differentiate this, I will get 2bt minus 3ct squared. Okay, so from here is my v as a function of t. So I can plug in to calculate my velocity. Velocity is 0. If I plug in 5 seconds, if you compute the number is 15 meters per second. And if I plug in 10 seconds, I get 12 meters per second. Okay. Then what was the question? C. How long after 0, that means how long after the initial time, the car is at rest again? So rest means what? 0 velocity, right? So let's say this. C. So rest, 0 velocity. Okay, so just now we have calculated our velocity to be 2bt minus 3ct squared. So rest means 0. This thing must be 0. So what is the time when this is at rest? So we can solve this equation for t, right? So what's the answer? Well, this is a quadratic, so let me factorize this. Okay, so you get two answers, either t0 or t is equal to 2b over 3c. So this is the initial time where it's already at rest. This is something we already know, right? So this one is we know. Then the other time is this answer. So it's 2b over 3c. So b was 2.4, right? So it's 2 times 2.4, and then c is 0.12. So if you calculate the number, you should be able to get 13.3 seconds. So 13.3 seconds later, the car will be at rest again, based on this equation. Follow so far? Am I going too fast or too slow? So I think everyone knows. I can go.
Dr. Lim,
Yes.
there seems to be a student raising a hand
Oh,
in Teams. Can you want to check?
yes. Hang on. Someone raising a hand.
If you click the participants list, I think you can see.
I
Oh,
saw.
I think
Yeah.
the student put down already.
We're done already. Yeah.
Sorry, I forget to
Oh,
raise my
Okay.
hand.
oh, it's okay. It's okay. Yeah, I know. Yeah, play. So yeah, in the Microsoft Teams, you can there's a raise your hand button if you want to ask question. Physical student just physically raise their hand, right? Sometimes I may not see because if I go to this screen, right, then I cannot see my Microsoft Teams. So if I don't notice you raising your hand online, you may need to use the voice because right now, if I open this, I can only see this. Okay. Anyway, so okay. Any question? Significant figure. This one is 2, right? So correct. Just follow 2. Yeah. Huh? Oh, yeah. Actually, right. What I want to say for significant figure is you follow and then you put one extra one is also fine as long as not less. Okay. So plus or minus 1, less by 1, plus by 1. You know what I mean? Extra 1, no problem. Less by 1, no problem. Okay. But for significant figure, I will be very relaxed. But for me and answering question, just do as long as you get the number correct means you're doing it correctly. Why? Because this is like these are like theoretical calculation. Significant figure, but for when you do the lab, then it will be more important. Okay. So yeah. Anyway, correct. You are correct. So for the online student, a physical student asked me significant figure actually should be 2 significant figure, right? Because the original question gave until 2 only. Okay, so yeah, you only gave until 2. So must follow the 2. Okay, so just say 13. Any other question? Yeah. So next thing to talk about is well, acceleration. And acceleration is just the same idea but applied to velocity, right? So now we know how to calculate the instantaneous velocity already, which is v as a function of t, and it is the differentiation of position. Okay, then we can define average acceleration in the same way. So because it's the same, I think I can go faster. If you're not sure, just ask me question. Average acceleration is just for velocity at a later time minus initial velocity and then the time interval. Okay, so it's just delta v, delta t. Okay, so that is the average acceleration, same thing. And then in the similar way, you can say instantaneous acceleration. Okay, so instantaneous acceleration is just a, and is the limit of the interval going to 0 for average acceleration, which is just differentiating v. Now, notice that v itself is a derivative of x. So that means my acceleration is the second derivative of position. Okay. So one way to imagine this is a simple way is this. Velocity is how fast you change position per time. Acceleration is how fast you change velocity per time. Okay. So acceleration is a changing of velocity. Velocity is a changing of position. Okay, so there are different levels that you can go. You can go up, you can go down, right? So you can go backwards by integrating, for example. Okay, but just to complete the discussion, let's talk about the dimension. Okay, so the dimension of acceleration is, well, the dimension of this operation, dv dt. Okay, so the limit is not important when it comes to it doesn't make a difference for dimension analysis. So it's this one. So it's basically just dimension of velocity is lt inverse. Dimension of time is t. So dimension of acceleration is lt minus 2. Right, just like the example I showed you just now. So therefore, the SI unit is meters per second square. Okay, so yeah, let's do another example, but I will do it quickly. I think it's, yeah, everyone is familiar with this, right? Hang on, let's see. Example 1.2.3. Let me check the software again. Yeah, I should check to see. Hands, everyone's okay. Still recording. Okay, so example. So now you are given the velocity of the car, right? So v of t is given as 60. So now this is 3 significant figures. Okay, so for those of you who are keeping track, t squared, right? And then find the average acceleration between 1 and 3 seconds. So yeah, so just do the calculation here, right? My average acceleration is just v at 3 seconds, v at 1 second, and then 3 minus 1. So if you plug in 3 seconds, you should get 64.5. If you plug in 1 second, you will get 60.5. Right, 3 minus 1 is 2. So in the end, is 2 meters per second squared. Okay, so this is my average acceleration. And then for part B is you're asking for instantaneous acceleration. So A is dv dt. Okay, so differentiating this. Now this one is a constant. So differentiating will be gone. Differentiating this will bring down a 2. So 2 times 0.5 is just 1. Correct? So you just get this expression, right? Yeah, so yeah, 1 meter per second 3, and then the t. Then once we have the expression, we can compute the acceleration at the different time. So you just plug in 1 second, 1 times 1 is still 1, so it's 1. And then if I want to calculate the instantaneous acceleration at 3 seconds, you plug in 3. 3 times 1 is 3. Okay, so this is my instantaneous acceleration at time 1, at time 3 seconds. The average acceleration throughout this period is 2 meters per second squared. Okay. Any questions so far? Okay. Okay, so one last section to, yeah, I guess we will do one last thing before we end, is to just now there was an online student who said that the formula half at squared for displacement is only valid when for 0 initial velocity. So now we will start to do this calculation more precisely, right? So now we are talking about the next part, formulas involving constant acceleration. Okay, so this is a special case, right? Special case where the A is constant. I say special case because sometimes you will get question where A is not constant. If A is not constant, you don't follow what you do here, right? But actually a lot of questions, maybe 70% of questions that you solve will involve constant acceleration. Then you will be good to use the formula here. Okay, so now if you know A is constant, right, can we calculate general formulas for velocity and position? We can, because remember that the definition of acceleration is the differentiation of velocity. And now we say that a is constant. Okay, so talking about initial velocity, right? So let us denote velocity be v0 at time 0. Okay, so when 0 seconds, the velocity is v0. So this is what we say the initial velocity. Okay, so that means, right, I can do this. Okay, so that means I can integrate both sides of the equation. Correct? Follow so far? Then if my velocity is time 0, this is how I put in the limit. So when time is 0, my velocity is v0. At some later time t, my velocity is some whatever v. Right? So I think this one should be quite straightforward. Okay, so if a is a constant, that means I can take it outside the integral. So I'm just integrating just 1 times dt. So I got a t, just like that, right? So from here, I bring this over.
Excuse me.
Yes.
What's the letter D mean? D. Yeah. What's the meaning?
Oh, this d?
Yeah.
This is the d from calculus integration. Do you know?
I think
so,
I got it.
It means that it close to 0 in infinitely, right? Or
correct. Yeah.
okay.
Thanks.
Yeah. So is this thing, and also yeah, because we were talking about dv dt, right? Is actually the limit of delta t going to 0, delta v delta t. So yes, to answer the question just now, let me repeat the question for physical student also. Someone online asked me what does the symbol d means, and the answer is it is the infinitesimally small displacement, right? So that means the t means very small delta t, right? Delta t can be any interval. We did not put a constraint to it, but if you consider to be very, very tiny, okay, then we use the symbol dt. Does that make sense? I'm jumping through all the details because this will be covered in your calculus class later, right? But as long as you understand this part, so we only use this thing up to this level. Clear? No problem? Okay, so yeah, any question, just let me know. But for now, what we have here is my velocity as a function of time. So we got one formula over here, right? So for constant acceleration. Now, given a velocity, we can integrate again to get the position, because furthermore, right, v is dx dt. So we can actually integrate this. So we can integrate dx is the integral of v dt. Can you see? Let me move this up. Okay. So we can put in the limit also. So let's say at time 0, my position is some position, not necessarily 0. Okay. And then at some later time t, my position will be some new x here. Okay. So can you integrate this function or not? Well, we can, because this v, right, we have the formula for v is over here. So we can put this here. Okay, so our formula now is, let me go to the new page. So my formula is integral from x to x is integral from 0 to t, and then v0 plus at 8 dt. Right, so just integrating this function. This is the initial velocity, so it's a constant. Right, so this one easy to integrate. It's just vt, and then integrate. This is also constant, so integrate this becomes half at squared, and then this becomes x minus x0. Okay, so from here, x minus x0 is the displacement, right? position at t minus initial position. So this is a displacement. Or you can just put x as the subject and move this over. Is the initial position plus vt plus half a t squared. Okay, so this is the what we call the kinematic equation for constant velocity. Right, so let me collect our information over here. So for the constant velocity case, sorry, I mean constant acceleration. Okay, so we got a is constant. Just now we derived a formula that says that v is v0 plus at, correct? And then x is initial x plus vt plus half at squared. Okay, so for now we have derived these three formulas, and this is what we call the kinematic equation for constant acceleration. Okay, now you may have learned this before, right? Kinematic equation, and you might remember probably there's another extra equation that I haven't mentioned yet, so I have it here. Okay, so this one I will let you try to derive yourself. I put it as a tutorial question. Okay, and we will talk about this in the tutorial. Okay, so we have 4 kinematic equations. I mean, there's many, like you can manipulate and substitute one into another, right? Equations as well, but these are the common using. Okay. Yeah. Any question? Does anyone have any question? So, okay. So I think there's no question. I guess that's all for our first class. Yeah. So sorry about the technical problem. We actually started a bit late because of our technical problem. We will continue talking about the rest in the Wednesday class, right? So other than that, yeah, anyway, the things you can, the necessary information you can find in the Moodle. So if you have any question, you can contact me through email or Teams or here. Okay. So let me stop the recording, and that's all for today. Yes. Yes, I want to do after I stop the recording. Hang on.